Welcome back to our C# bootcamp. In this session, we're going to explore the object lifecycle and garbage collection. These are very critical concepts for understanding how memory is managed in .NET. Let's dive in. First, what exactly is object lifecycle? We can say the object lifecycle refers to the stages an object goes through during its existence in my application, from creation to destruction. So we have actually like 5 stages. The first one we can call it allocation, which we're gonna use the memory, or the memory is gonna be allocated for the object when it's created. Second, we have initialization. That one, once the constructor is used or is called it to initialize the object. Number 3 gonna be the usage of our object. In that case, we're gonna say the object is actively used in the application. Number 4 gonna be the garbage collection itself. When no longer needed, the object become eligible for garbage collection. And the last one gonna be destruction. That one, the object memory is reclaimed and its resources are released. But let me here as well define what exactly a garbage collection. It's a feature built in on .NET runtime, which is gonna be responsible for automatically reclaiming a memory occupied by unused object. So we can say garbage collection, it's a process, definitely, build or which .NET runtime identify to reclaim memory used by object. And that one gonna simplify the memory management by freeing developers from manually deallocating a memory. If anyone of you worked before with C++, in that time we are doing extra step or extra milestone to deallocate the memory after we are using the object. So let me say as well how garbage collection gonna work. I'm gonna break it down how gonna work in .NET before going for the advantage and when to use this one. Actually, it's like 3 steps, very straightforward. The first one, marking. The garbage collection gonna identify all the objects that are still in use. Second one gonna be sweeping. It's gonna reclaim memory used by objects that are no longer reachable. And the last one gonna be compacting. The garbage collection compact the memory to reduce fragmentation and improve performance. So I'm gonna say garbage collection is gonna be something like non-deterministic, which means it's gonna run automatically when needed, not at a fixed time. The advantage of using this kind of freeing memory definitely, and gonna do some kind of automatic optimization, because garbage collection gonna optimize performance by reclaiming again the memory efficiency. But here in the previous slide, we saw something like garbage collector operate in generations G0 or generation 0, 1, and 2. What exactly are these? In .NET garbage collection, to optimize performance, the GC or garbage collector use some kind of generalized model, which are gonna be separated or slide on 3. Generation 0 contain a short-lived object, what we call it local variable. And generation 1 act as a buffer between a short-lived and long-lived object. And on the other hand, generation 2 contain a long-lived object, some kind of static data or application-wide object. That kind of object that survive garbage collection in generation 0 are promoted to generation 1, and so on. This approach gonna improve efficiency by focusing on collecting short-lived objects first. And what we try to highlight it here in the slide, it's gonna be prioritize short-lived object for collection. So inside this code, inside Visual Studio, gonna demonstrate how file handler are implementing IDisposable. And if you're gonna scroll down here, we are using this keyword. That one gonna ensure that the file stream probably released when the object is no longer needed. So this using statement or keyword gonna simplify the process. So the best practice here for garbage collection, always use the using keyword or statement for resource management to automatically release the resource when no longer needed. As well, try to minimize use of finalizer. Better use IDisposable, that one for deterministic cleanup. Even avoid large object allocation in loop, and dispose always unmanaged resource explicitly. So let's quickly overcome here what we are trying to cover throughout this session. That by understanding the object life cycle and garbage collection, it's just like a key to write efficient and reliable C# application. In the next session, we're gonna explore another topic.